All right, let's pull back the curtain on one of the most important but kind of invisible pieces of technology in our lives. We're talking about the powerful engine that makes our entire digital world go round. From your bank account to your social media feed, we're talking about the database. So let's dive right in.
To really get a handle on this engine, let's start with something super simple. An action that we all do. Something that feels like it happens in an instant, but is actually hiding an incredible amount of complexity.
You know the feeling. You find that perfect pair of jeans online, you pop them in your cart, you enter your details, and you hit that magic Buy Now button. It feels so simple, right? A single click, and they're on the way. But what is actually going on in that split second?
Well, that one little click, it kicks off this lightning-fast conversation. Your request has to check if the jeans are in stock, it has to verify your payment, update your order history, and schedule the shipping. And all of this is managed by a piece of software called a Database Management System, or DBMS. You can think of it as the librarian, the security guard, and the traffic cop for all that data, all rolled into one.
So the first huge problem a DBMS has to solve is just basic organization. I mean, without it, you'd have total data chaos. How does it store all this information so that it can be found again in like a millisecond?
I mean, without a system, finding data would be like trying to find one specific sentence in a library where all the books have just been thrown into one giant pile on the floor. It's a hopeless task. The solution is to create a formal blueprint for the data, and that blueprint is called a schema.
For a long time, the go-to blueprint has been the relational model. It basically simplifies everything by organizing data into simple tables, kind of like a superpowered spreadsheet. Now, it's not the only way. There are newer models, often called NoSQL, that handle different kinds of data chaos. But the relational model is really the foundation. As you can see here, each core idea, like a customer or a product, gets its own table. That's an entity. And the connections between them are relationships. This simple structure is what brings order to all that chaos.
Okay, so our data is all neat and tidy in these tables. Fantastic. But now what? How do we ask it questions? How do we have that high-speed conversation we were talking about earlier? Well, we need a language that both we and the database can understand.
And that language is SQL, Structured Query Language. Now, I know it might look a little techy, but it's actually more like a very, very precise English sentence. This query here, it's just asking the database, hey, show me the names of all the sailors who have a rating higher than 7. See? It's a clear, direct instruction.
But here's where it gets really, really clever. When the DBMS gets this query, it doesn't just start searching blindly. No way. It has this genius little component called a query optimizer that acts like a master strategist. It looks at the query, it considers all the different ways it could possibly find the answer, and then it picks the absolute fastest, most efficient route to get you your data.
So the DBMS finds the fastest path to the data. But honestly, finding the data is just the beginning. To make your Buy Now click actually work seamlessly, the system has to perform what I like to call 3 incredible feats. 3 little miracles, all in the blink of an eye, just to stop the whole thing from falling apart.
First up, speed. Think about a huge online store with billions of past orders. When you want to see your order history, you can't sit around waiting for the system to read through every single order ever placed. So how on earth does it find yours instantly?
The answer is indexing, and it works exactly like the index at the back of a textbook. Instead of reading the whole book cover to cover to find one topic, you just look it up in the index, and boom, it tells you the exact page number. A database index does the exact same thing for your data, letting the DBMS jump right to the record it needs without scanning everything else. It's the secret to its incredible speed.
All right, on to the second miracle, handling crowds. Picture this, the very last ticket for a massive concert goes on sale. Thousands of people all hit buy at the exact same moment. How does the system sell it to just one person without crashing or, selling the same ticket 1,000 times? This is where the DBMS turns into a traffic cop. It's all handled by something called concurrency control. When a transaction, like buying that ticket, needs to change some data, it has to get what's called an exclusive lock. And while it has that lock, nobody else can touch that specific piece of data. Everyone else has to wait in line. This system makes sure transactions happen one at a time, preventing total chaos and keeping the data clean. And that brings us to our final miracle, the safety net. You've clicked Buy Now. The money has just left your bank account. But right before the system confirms your order, the power goes out. Is your money gone? Is your order just lost in the void forever?
Absolutely not. And that's because the DBMS has this amazing safety net called a transaction log. Before it makes any change to the real data, it first writes down what it's about to do in this special indestructible log file. It's like the database's black box. So if a crash happens, when the system restarts, it just reads the log. It can see if your transaction finished. If it did, it makes sure that change is permanent. And if it didn't, it just rolls the whole thing back, like it never even happened. No data is ever lost.
So, organizing data, speaking its language, and pulling off these miracles of speed, concurrency, and safety, these are the core jobs of the DBMS. Let's zoom back out and ask the big question. Why is this so fundamental to our digital lives?
Well, just think about it. Every single one of these systems, the things we rely on every single day, is built on top of a database. Without the guarantees that a DBMS provides, online banking would be a nightmare, e-commerce would be pure chaos, and social media would just grind to a halt. It really is the foundation of the modern internet.
So the next time you tap your phone to check your bank balance or book a flight or even just like a photo, you'll know what's happening behind the scenes. You'll know about that silent, powerful engine that's making it all work, performing those little miracles to make sure your digital world is orderly, safe, and incredibly fast.
And that leaves us with a final thought. We are creating more data now than at any other point in human history. The demands on these systems, they're only going to get crazier. So the real question is, as data becomes the world's most valuable resource, who are the people that will build the next generation of databases powerful enough to manage it all?